while loop, but the first thing a do while loop does, instead of checking this condition down here, is it executes all of this code. So even though index is equal to 6, we're still going to print out 6 and we're still going to increment it. And then we're going to check the condition to see if we can keep looping. So let me show you guys this, and this should illustrate what this is doing. And actually I need to put a semicolon here. So you can see over here we're printing out 6. So unlike before when we just used that while loop, now because we're using a do while loop, we're doing whatever was inside of that loop before we're checking the condition. And there's going to be certain circumstances where a do while loop will come in handy. I would say by far while loops are way more common. But just, it's good to know about do while loops because there are certain circumstances where they'll come in handy. Basically, anytime you don't want to be checking the condition first, you can use a do while loop. But those are the two basic types. And there's actually another type of loop that we'll talk about later in the course, which is called a for loop. But for now, we're going to have some fun with while loops. And in the next tutorial, we're going to be building a little guessing game. In this tutorial, I'm going to teach you guys how to build a little guessing game in C. This is going to be pretty cool because we're going to use a lot of the stuff that we've learned up to this point in the course in order to build it. So let's get started. Basically, this guessing game is going to allow the user to guess a secret number. So we're going to define a secret number, and we're going to give the user the opportunity to try and guess it. So if they'll try to guess it, if they get it right, then they'll win the game. And if they don't get it right, then we'll let them guess again, right? So we'll basically let them keep guessing what the secret number is until they get it. So down here, we want to create a couple variables. The first variable I want to create is going to be an integer, and it's going to be the secret number. So I'm just going to call it secret number, and why don't we just set it equal to 5? The next variable we want to create is going to store the user's guess. So this is also going to be an integer, and I'm just going to call it guess, and I'm not going to give it a value yet because right off the bat, the user wouldn't have guessed a number. So what we want to do is we want to be able to prompt the user to enter in the number until they get it right. So as long as the user hasn't entered in the correct number, we want to keep asking them to enter it in. In order to do that, in order to keep asking them to enter it until they've guessed it, we can use something called a while loop. So I'm just going to type while, and I'm going to make an open and close parentheses and an open and close curly brackets. Let's think about a good condition for our game. Basically, we want to keep asking the user to enter an input as long as they haven't guessed the secret number. So it's right there. We could keep looping as long as the guess is not equal to the secret number, right? And basically, this is always going to be true until they guess the correct number. Now, inside of here, we want to prompt them to enter their guess, and then we want to take whatever they enter and store it inside of our guess variable. So let's do this first. We'll say printf, and I'm just going to say enter a number. And then down here, I'm going to use scanf in order to get whatever number they enter. And I'm going to store it inside of that guess variable. So I'm just going to say @guess. And this is going to take whatever number, whatever integer they enter, and it's going to store it inside of our guess variable. So basically what's happening in this loop is every time through the loop we're getting a different number, and then we're going to come up here and we're going to check to see if it's equal to the secret number. If it's not, then we're going to go through again and we're going to keep doing this. But if the guess is equal to the secret number, then we'll break out of the loop, and that means we'll be down here. So I'm just going to print out a success message, and I'll basically just say hey, you win. All right, awesome. So you can see this isn't actually that many lines of code. I mean, it's probably 10 lines of code to write out this whole thing. And it looks like everything's set up, so this should actually work properly. So let's try to run this, and we'll see if we can guess the secret number. So remember, secret number is 5. So I'm going to run the program. It says enter a number. So let's just kind of botch the guesses. 2, 7, 8, 9, 3. So you'll notice I can keep entering in numbers, and it'll keep prompting me to enter a number as long as I haven't guessed it correctly. So now let's type in 5, and remember 5 is the secret number. When I click enter now, that loop condition is going to end up being false, right? Because the guess is going to be equal to the secret number, and it's going to execute, and it's going to say, hey, you win, right? So we broke out of that loop, we executed the print statement that said you win, and the program terminated. And that is a really cool little game. So one of the cool things about this game, and it's different from programs that we've written in this course in the past, is it'll keep running essentially infinitely until we enter in that correct guess. So it's going to keep going and keep going and keep asking us to do something and to enter in a value until we entered correctly. So this is pretty cool. Now this is a pretty nice game, and it's pretty simple, but I want to maybe make it a little more complex. One of the things that sucks about our game right now is that the user gets unlimited guesses, right? So basically, like, they can just guess every single number and eventually they're going to get it right, you know? So why don't we do this? We should impose a guess limit. So why don't we say, like, the user can only guess 3 times, and if they can't get the secret number in 3 tries, then they'll lose the game. So let's think about how we can go ahead and add that functionality into this little app. I'm going to walk you guys through how we can do that. The first thing we're going to need to do is we're going to need to create some variables. I'm going to create another variable up here, and I'm just going to call it guess count. And guess count is basically going to tell us how many times the user has tried to guess the secret number. And I'm just going to set this equal to 0 because initially the user will have guessed 0 times. So remember, this guess count variable is basically going to get incremented every time they guess, right? So I'm going to come down here. Every time we go through this loop, the user is guessing. So every time we go through this loop, I'm going to increment the guess count. So I'm just going to say guess count plus plus. And that means every time the user guesses, the guess count will get incremented and we'll have an accurate count of how many times the user has guessed. All right, the second variable that I want to make is going to be another integer, and I'm just going to call it guess limit. And this is going to tell us how many times the user can guess. So this will basically determine, like, how many guesses the user gets. So why don't we set this equal to 3? I think 3 guesses is a pretty good limit. And finally, we want to create one more variable. And this is also going to be an integer, and I'm just going to call this out of guesses. And I'm going to set out of guesses equal to 0. And out of guesses will basically tell us whether or not the user has any more guesses. And this might not be super clear what this is doing right now, but keep following with the video and you'll see how this comes into play. This is actually going to be really important. So we're actually going to have to modify our code a little bit. So down here, we have this set up so the user can keep guessing as long as the guess isn't equal to the secret number. Right. But we want to be able to limit the amount of times that the user can guess. And actually down here, I'm going to create an if statement. And every time we go through this loop, I want to check and see if the user has any more guesses left. In other words, I want to see if they've reached their guess limit or not. So I'm going to make an if statement, and I'm going to check to see if the guess count is less than the guess limit. As long as the guess count is less than the guess limit, that means they haven't guessed as many times as the limit specifies. Basically, they can guess again. Right? So down here inside of this if statement, I'm going to put all of this code, and I'm just going to surround this with curly brackets. So basically, the user can only guess the number. This code will only get executed when the guess count is less than the guess limit, when the user has additional guesses, right? When they haven't guessed as many times as the limit specifies. Otherwise, though, so if they have guessed too many times, right, if the guess count is either equal to or greater than the guess limit, I'm actually going to set this out of guesses variable equal to 1. So I'm going to say out of guesses is equal to 1. And basically what this is going to tell us is if out of guesses is greater than 0, then that'll tell us that the user is out of guesses. So essentially, if out of guesses has a value that's more than 0, we'll know that they've run out of guesses. And if you ever use any other programming languages before, this is what we refer to as like a Boolean variable. It's basically storing like a true or a false value, which we're representing with 0 or 1. So if the guess count's less than the guess limit, they can guess again. Otherwise, we're going to say out of guesses is equal to 1. In other words, we're going to say that they're out of guesses. There's one more thing we have to do, though, is we have to come up here and we have to change this condition. Because right now, we're going to keep looping through this code as long as the guess is not equal to the secret number. But there's actually two situations where we want to break out of the loop. The first is when they've guessed the number correctly, right? Then we want to come down here and print out you win. But we also want to break out of the loop when they've run out of guesses. So I want to check to see whether or not they're out of guesses. So I'm going to say guess is not equal to secret number and out of guesses is equal to 0. So as long as out of guesses is equal to 0, that means that they're not out of guesses and they still have some guesses left. But if the guess count's less than the guess limit and out of guesses gets set equal to 1, then out of guesses isn't going to be equal to 0 anymore, so we're going to break out of the loop. So basically there's two scenarios now that will break us out of the loop. Either they get the word right or they run out of guesses. So one more thing we have to do in this program is come down here, and you'll see down here we're always printing out you win. So no matter what happens, we're printing out you win. And that's because before, if they made it down here, if they made it out of that loop, that means that they guessed the secret number correctly. But there's actually two scenarios down here where they would have broken out of the loop, where they're either out of guesses or they guessed the secret word. So I want to actually check to see which one we're dealing with. So I'm going to check to see if out of guesses, and I'm going to check to see if it's equal to 1. And if it's equal to 1, that means that they lost and they ran out of guesses. So I'm just going to say out of guesses. Otherwise, though, it means that they won. So I'm going to say you win. And this will basically be like, hey, you won the game. Awesome. So this is a lot of code, I know that, and let's just run this, see how we did, and we'll see if our game's working properly, and then I'll kind of explain all the code to you guys. And actually, you know what, I just noticed a typo. Down here I said out of guesses double equals 1. This is just has to be a single equal, so we're assigning this a value. So yeah, that was a little typo. I had 2 equals, that needs to be 1. So let's go over here, we'll run our program, and it says enter a number. So why don't we try to lose the game? I'm just going to say 2, 2, and now we're on our third and final guess. If I don't get it this time, that means we're going to lose the game. So I'm going to enter, and you'll see it says out of guesses. So we weren't able to guess it within our 3 tries, and the game told us that we lost. Let's run it one more time, we'll try to win. So I'll say like 2, 1. Now we're on our third and final guess. So if I don't get it this time, we're going to lose. I'm going to guess a 5. And we guessed right, so it's going to tell us that we won. So that's sort of basically how this little program works. And I'm going to walk you guys through one more time. So we have all these variables up here. Secret number is just storing the number they need to guess. The guess keeps track of what they're guessing each time. The guess count is going to tell us how many times they've guessed the number. Guess limit is going to tell us how many times they can guess. And out of guesses is going to tell us whether or not the user is out of guesses. So down here, we're checking 2 conditions for this while loop. We're checking to see guess is not equal to the secret number, and we're going to keep looping as long as out of guesses is equal to 0. Every time we go through this loop, we check to see if the guess count is less than the guess limit. If it is, then we ask them to guess, we increment the guess count. Otherwise, we say out of guesses is equal to 1, and that's going to break us out of the loop. Down here, there's 2 situations. The first situation is that they ran out of guesses. The second situation is that they won the game, and we're using this if statement to check both of those. So that's basically how this works, and this kind of shows you how we can use things like while loops and if statements and also variables together in like one single program. And this is
AT&T's been carrying America's calls since 1876. When you've been around that long, you can spot a hustle coming from a mile away. T-Mobile is the master of breaking promises. While T-Mobile stays caught up in untruths, AT&T keeps building what matters, America's most reliable network. Right, Graham? When you compare, there's no comparison. Plain talk, strong signal, nothing better.
In this tutorial, I'm going to teach you guys how to use for loops in C. Now, a for loop is a special type of loop that we can use in C, which allows us to use something called an indexing variable. And this indexing variable will basically tell us what iteration of the loop we're currently on. And we can use that indexing variable to do a bunch of stuff, like we could loop through an array of items. We could do all sorts of stuff inside of a loop. So down here in my program, you'll see that I have a while loop set up. And I have just sort of a basic while loop. And I want to show you guys what it's doing. So essentially up here I'm saying int I is equal to 1. So I'm giving this integer I the value of 1. And I'm saying while I is less than or equal to 5, I'm going to print out the value of I, and then I'm going to increment I. So this is a very simple while loop. Basically we have this variable I, and every time we go through the loop we're printing it out until it's greater than 5. So let's run this program and we'll see what it does. So you'll see over here we're basically printing out values between 1 and 5. And I want to point out what's actually happening. So the first time that we go through this while loop, we're printing out 1. The second time, we're printing out 2. The third time, we're printing out 3. In other words, this variable I is basically telling us what iteration of the loop we're currently on. So on the first iteration of the loop, I is telling us that we're on the first iteration of the loop, right? The first time we go through the loop, I is equal to 1. Second time we go through the loop, I is equal to 2. Third time, I is equal to 3. So this variable I over here is basically telling us how many times we've gone through the loop. So on the third time, it's telling us 3, fourth time, 4, etc. And believe it or not, this is actually a very useful thing for us to have when we're looping. And so there's a lot of situations where you're going to want to know what iteration of the loop you're currently on when you're looping. So with a normal while loop, like I can basically just specify a condition up here and I can do whatever I want, right? It's very open. You can kind of just do whatever you want with it. But in a lot of situations, and there's tons of these situations, we're going to want to have a variable just like I that will tell us what iteration of the loop that we're currently on, or basically just a variable that's going to keep changing every time we go through the loop. And this is such a common situation in C that there's actually something called a for loop. And a for loop allows us to take all of this code and condense it into its own single loop. So it's taking this situation where we want to have a variable like I, and it's basically allowing us to do it a lot easier and a lot cleaner. So I'm going to show you guys how we can create a for loop. I'm going to come down here below this while loop, and I'm going to create a basic for loop structure. So I'm just going to say for, I'm going to make an open and closed parentheses and an open and closed curly bracket. Now, the difference between a for loop and a while loop is basically going to happen inside of these parentheses. So in the parentheses of a while loop, we have our loop condition or our loop guard, right? This is specifying whether or not we can keep looping through. Inside this for loop, we're going to have 3 different things. So instead of just one loop guard, we're actually going to have 3 different things that we want to put inside of here. So with a for loop, the first thing I'm going to put in here is this variable I. So you'll notice in the while loop, we have our variable I up here, and this is basically allowing us to loop through and keep track of how many times we've gone through the loop. So what I can do down here is I can do something similar. I could say like int I, and I'm not going to give this a value. Inside of here, I'm going to say I is equal to 1. So basically, I'm going to take my variable I, and I'm going to give it an initial value of 1. And now I have my I variable. I have my variable that's going to change every time we go through the loop. The next thing I want to do is include my looping condition. So up here we have I is less than or equal to 5. That's our condition. I can put the same thing down here. So I'm going to say I is less than or equal to 5. The third thing I want to do is increment I. So you'll notice down here, every time we go through this loop, we're incrementing that variable I. I'm going to do the same thing over here in this little third quadrant. So you'll notice I have these little sections. Here's the first section. We're initializing the variable I. We're saying I is equal to 1. Here we're specifying our looping conditions. So I'm saying we're going to keep looping while I is less than or equal to 5. And over here is a little line of code that's going to get executed every time we go through the loop. So here I'm saying I++. I could also say like I minus minus, and that would decrement I. I could say like I is equal to I plus 2, etc. Like I could do basically anything I wanted over here. Let's just keep it at I++ for now. So you'll see I was basically able to take all of this code and condense it into its own little type of loop. And now instead of having to like print this out and create this variable up here, I can do all of that inside of this for loop. Now I could basically take this line of code, I could paste it down into here, and we essentially have the same thing. So right now, this block of code and this block of code are 100% equivalent. They're doing exactly the same thing. So let's go ahead and get rid of all this code, and let's test out our shiny new for loop. So I'm just going to run my program, and you'll see over here we're getting to like print this out and create this variable up here. I can do all of that inside of this for loop. Now I could basically take this line of code, I could paste it down into here, and we essentially have the same thing. So right now, this block of code and this block of code are 100% equivalent. They're doing exactly the same thing. So let's go ahead and get rid of all this code, and let's test out our shiny new for loop. So I'm just going to run my program, and you'll see over here we're getting exactly the same thing that we got before. We're printing out 1, 2, 3, 4, 5. So it's the same exact program doing the same exact thing. And that's why for loops are great, because we can take that little structure like where we have an indexing variable and we can use it with something like this. So I want to show you another situation where these for loops can come in handy, and we can use them to loop through all of the elements inside of an array. So actually up here I have this array that I created. It's called lucky numbers, and I'm just going to grab this and bring it down here. So we have this lucky numbers array. It has 4, 8, 15, 16, 23, 42. And what I could actually do is I could loop through all of the elements inside of this array from this for loop. So I'm going to show you guys how we can do that. Now let's first off see how many elements we have. We have 1, 2, 3, 4, 5, 6. We have 6 elements in this array. So what I'm going to do is I'm actually going to say I is equal to 0. And you'll see why we need to do this in a second, but basically array indexes start at 0. So this first element in the array is at index position 0. And just for a little refresher, if I wanted to access one of these elements from inside the array, I could say like lucky numbers with 0, and this is going to give me access to this element. If I said lucky numbers 2, then I'll get access to this element, this 15. So this is basically how we can access an element inside the array. So I'm going to set I equal to 0, and I'm going to say I want to loop while I is less than 6. And 6 was how many elements we had in the array. So I want to keep looping as long as we're less than 6. And I'm going to say I++. Now, down here, I'm going to do this same exact thing, but instead of printing out I, I'm going to print out lucky numbers I. So I'm going to print out the array element at index position I in lucky numbers. Basically, the first time we go through this loop, we're going to be printing out lucky numbers 0. Because I is going to be equal to 0. The second time we go through the loop, we're going to be printing out lucky numbers, I is going to be equal to, etc. And we're going to keep doing that all the way to 5, the last element, which is 42. Let's go ahead and do that. So I need to put this back to I. And let's run this program. So you'll see over here, we're basically doing exactly what I said. So the first time we're printing 4, printing out that first element. Second time through the loop, we're printing out 8, which is the second element. 15, 16, 23, and 42. So we're printing out all of those elements in turn as we go through this for loop. And there's a lot of situations where for loops are going to come in handy, but this is a very, 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 very common situation where we want to loop through all the elements in an array and either print them out or do something to them, whatever. So that's the basics of working with for loops. And I do just want to say, like, anything that you do with a for loop, you can do with a while loop. I basically showed you guys how we transformed that while loop into a for loop. The thing with for loops, though, is that they're very convenient, so it makes it really easy to do something like this without having to go through all the trouble of creating a while loop.
Cool, iPhone 17? I switched to T-Mobile.
You get 4 iPhone 17s on...
Wait, who's taking the picture?
Get 4 amazing cameras on Slush 4 lines for just $25 a line.
Step into the world of Nespresso and bring magic to every morning. Shop the holiday gift collection at Nespresso.com.
In this tutorial, I'm going to talk to you guys about 2 topics in C. The first topic we're going to talk about are 2-dimensional arrays. A 2-dimensional array is basically a situation where we have an array where all of the elements in the array are actually arrays themselves. The second thing I want to talk to you guys about is nested loops. So we're going to look at how we can use a looping structure where we have a loop inside of a loop. So it's going to be pretty cool. And actually, these 2 topics can go together really well. And I'm going to show you guys how we can use nested loops and 2-dimensional arrays in order to make an awesome program. So let's get started. The first thing I want to show you guys is 2-dimensional arrays. So down here, we can create a 2D array. And the concepts that I'm doing in this video can apply to multi-dimensional arrays, so not only 2 dimensions, but 3, 4, 5, really as many dimensions as your heart desires. So in order to create a 2-dimensional array, I'm just going to make an array of numbers. So I'm just going to say int, and we'll give this a name. So why don't we just say nums. And normally when we create an array, after we'd say the name of the array, we'd make an open and closed square bracket. But when we create a 2-dimensional array, we're going to make 2 open and closed square brackets, just like that. These 2 open and closed square brackets will basically represent like the width and the height of our array. So you guys will see what I mean in a second. But basically, we're going to have like elements in the array, and then each of those elements is going to be an array, and we'll have elements inside of it. So these 2 squares will allow us to like manipulate all that stuff. So what I'm going to do is I'm going to set this equal to an open and closed curly bracket. Now this is normally how we would create an array. So normally I would just say like 1, 2, 3, 4, whatever. I could put all my numbers in here. But with a 2-dimensional array, all of the elements are going to be arrays. So instead of just saying like 1, 2, 3, we're actually going to create arrays inside of here. So for example, I'll put an array right here. And this text editor is so annoying with making these. So, for example, the first element in this array, I could just make an array. So I'm going to say this is like 1, 2. So you can see here, I have 2 elements inside of this array, which is itself the first element of the nums array. So let's make another one. I'm going to come down here and we'll make another one. And this keeps trying to format differently. So now we're going to say 3, 4. So this thing right here, this whole array, that's the first element in the nums array, right? And that array has 2 elements inside of it. Same thing with this one. This is the second element in the nums array, and it has 2 elements inside of it. So it's basically an array within an array. Let's make one more, and so this is going to be 5, 6. So now we have 3 array elements, right? 1, 2, 3, and each of them has 2 elements inside of them. So whenever we create a 2-dimensional array like this, we always have to specify the number of elements and then the number of elements inside each array. So in our case, we're going to have 1, 2, 3 elements in the array, and each array has 2 elements inside of it. So it's going to look like that. So we would say 3 and then 2. And that's basically how we create it. So now let's talk about accessing these elements. So I'm going to create a little print statement here. And we're going to print out some of this stuff. So I'm going to say %d, and I'm going to show you guys how we can access individual elements. So basically, I'm going to say nums. And let's say that I wanted to access this top left element, this 1. The first thing I want to do is specify the index where the value that I want to access is stored. So like this would be index position 0, this would be index position 1, this would be index position 2. So we're going to say 0. And then I want to specify the index position of the individual element inside of 0. So I can say like this is element 0, this is element 1. So why don't we access element 0? So I print out nums 0, 0, and this is going to print out that number. So it's going to print out that 1 for us. So you can see over here we get that 1. So let's try a different one. Let's try to grab this 4 right here. So this is going to be at index position 1, and then 1. So this will be at 1, 1. And now we should get that 4. Let's see. Yeah, cool. So we get the 4. Alright, so that's basically how we can access elements inside of these arrays. And I also just want to point out that if I didn't want to give this an initial value, I could just like put a semicolon here, and I could just like manually define each index location. So I could say like 0, 0 is equal to 7 or something. I don't have to give it a value like right up front. Although in our case, let's just do it because it's a lot easier. Alright, so we have our nums array, and we figured out how we can print out the elements. So now I want to talk to you guys about another concept, which is called a nested for loop. And you guys will see in a second why I'm teaching this alongside 2D arrays. But a nested for loop is a situation where we have a for loop, and inside of that for loop, we have another loop. So I'm going to show you guys this really quick. Let's say we create a for loop. I'm going to create 2 variables over here, int I and int j. And I don't know if I've showed you guys this in the course yet, but if I want to just like declare 2 variables, I can just say I, comma, j, and that'll declare both variables. I'm not giving them actual values yet. We're going to do that inside these for loops. So I want to show you guys how we can use a nested for loop in order to print out all of the elements inside of this 2-dimensional array. So I'm going to say for I is equal to 0, and we're going to keep looping as long as I is less than 3. And the reason I'm saying 3 here is because that's how many elements are inside of this nums array. So I'm going to keep looping as long as I is less than 3, and then I'm going to say I plus plus. Now, inside of these curly brackets, I want to create another loop. So every time we go through this one iteration of this top loop, we're going to fully execute through another loop. So I'm going to say for j is equal to 0, j is less than 2, and the reason I'm saying 2 here is because that's how many elements are inside each array inside of the nums array. And you guys will see in a second why this is going to work. And then I'm going to say j plus plus. So now I'm going to make some more open and close curly brackets, and down here I'm going to actually be able to print out all of the elements inside of this array. So I'm going to go ahead and do that. I'm just going to say printf, and we're going to be printing out an integer because these are all integers, and we're going to be printing out nums, and I'm going to print out nums I and j. So whatever the value of I is and whatever the value of j is, that's the index position inside of nums that we're going to print out. And now just so this is formatted a little bit better, why don't we put a comma right there. And then I'm also going to put another printf over here. That's just going to print out a new line. And you'll notice that this printf is outside of this inner for loop. So I'm going to run this program. We're going to see what it does. You guys will see exactly what's happening, and then I'll sort of walk you through a little bit more what is going on. So let's run this program. And you'll see over here when we ran the program, we're basically getting this entire 2D array printed out. So I'm printed out 1, 2, 3, 4, 5, 6. So let's talk about why that happens. Over here, I'm saying for I is equal to 0, I is less than 3, I plus plus. So I'm going through this particular for loop 3 times. I'm going to execute all the code inside of this for loop right here 3 times. That's as many times as there are elements inside of our 2D array. Now, every single time I go through this top loop, every single time I go through it, I'm going to execute this loop in its entirety. So I will loop through this loop all the way through. I'll go through all of its iterations. And this loop says j is equal to 0, j is less than 2. And 2 over here is how many elements are inside of each one of these arrays. So this element in the nums array has 1, 2 elements inside. This element in the nums array has 1, 2 elements inside of it, right? That's where this 2 is coming from. Then I'm incrementing j, and I'm going to print out, so I'm saying printf, and I'm printing out nums at index position I and index position j. So the first time we go through this for loop, I is going to be equal to 0. And remember, that first time, we're actually going to be going through this loop 2 times. So we're going to be printing out nums 0, 0 and nums 0, 1. And then we're coming down here and printing a new line. The next time we go through this I loop, we're going to come down here and print nums 1, 0 and nums 1, 1. Finally, the third and final time, we're going to print out nums 2, 0 and nums 2, 1. That's basically how this is working. So two-dimensional arrays and nested for loops are a match made in heaven. And there's a lot of situations where, besides just looping through 2D arrays, that we're going to use nested loops. But hopefully this gives you a little bit of an introduction into what they are and why they're useful.
It's the personal price plan theorem. If you bundle home and auto, that can equal an affordable price just for you. Bundle and save with the personal price plan. All right. Yeah. Like a good neighbor, State Farm is there.
In this tutorial, I'm going to talk to you guys about accessing memory addresses in C. Now, in the C programming language, a lot of times we're going to want to store different information, right? And there's a bunch of different ways that we can store information. We can use things like variables, we could use arrays, we could use structs. But the basic point is that whenever we're using C, we're going to want to keep track of and maintain a bunch of different pieces of information. And one of the easiest ways to do that is by creating variables. So down here, you'll notice that I have a bunch of variables. I have this integer called age, and it just has the value of 30. We have this double GPA, 3.4, and we have this character grade, and it has the value of the A character. I have a bunch of different variables in my program, and it allows me to keep track of data really easily, and I can use these to, maintain, and I can even modify these different informations. Variables are great, but I want to talk to you guys a little bit about how these work in the actual physical memory of our computer. So whenever I create a variable, for example, when I create a variable called age and I give it a value of 30, this value 30 actually gets stored on our computer. So all computers have memory. So a lot of times you'll hear people refer to this as RAM. It's called random access memory. And basically RAM is the memory that your computer is going to use when it's running programs. So for example, if I was to run this C program, my computer would use RAM, it would use that memory in order to store and keep track of all this different information. Right? So when I create a variable like int age, C is actually going to store this value 30 at a specific memory location. So it's going to take that value 30 and it's going to store it somewhere in RAM. Right? When I create this double called GPA, C is going to take this value 3.4 and it's going to store it inside of the physical memory on our computer. When I create this grade, C is going to store this character in the physical memory in our computer. Now, here's the thing. When I create these variables, I give them descriptive names, right? So I gave this a descriptive name, age, so I know what's stored inside of it, right? And when I want to access this value, I can just refer to the name, right? I can just refer to age. I could modify it. I could print it out. I could do something else to it, right? I can do whatever I want with it. And the way that I can access this variable, in other words, the way that I can access the value 30 is just by referring to the name of the variable. Same goes down here. If I wanted to access the grade, right, if I wanted to access this capital A, I could just refer to the name of the variable. But again, here's the thing. All of this information is stored in our physical memory somewhere. And so whenever C needs to access that information, whenever our computer needs to access this value 30 or this value 3.4, it's actually going to refer to a specific memory address, right? So when I want to access this variable age, I can just type out age and then I can use this variable. But when C wants to refer to this value, it's not actually using age, it's going to use the memory address where this value is stored inside of our physical memory. So all of these values are stored inside of a physical address in our memory. So all of these values have an address where they're stored in memory. And when C needs to access them, it can use that address. So I'm going to show you guys how we can access that address, how we can print out the address onto the screen, And basically just wanted to give you guys an introduction into what memory addresses were. So down here I'm going to say printf, and I'm going to show you guys how I can actually print out the physical memory address where each one of these values is stored on our computer. So down here, if I want to print out a memory address, I need to use a % and a P. So normally if I was just going to print out like a number, I could say like %D, or I could say %C for a character. When we want to print out a physical memory address, we're going to say %P. And this actually stands for pointer. We're not going to talk about pointers in this tutorial, we're just going to talk about memory addresses. But just know that you need to say %P. And now I'm going to type out the name of the variable whose memory I want to access. So I'm going to access the memory address of age. And before the variable, I'm just going to say ampersand. So I'm going to make an ampersand age, and I'm going to say %P. And now we should be able to print out the memory address where the variable age is stored. In other words, we can print out the memory address where this value 30 is stored. So let's go ahead and run our program. And you'll see over here we're getting this number. So I'm getting this number 0060FF00. So this would be like a hexadecimal number. I guess it's not technically a number. It's like, I think it's hexadecimals. But basically, this is the physical memory address where the value of 30 is stored. In other words, it's the place where C stored the value inside of this age variable. I could do the same thing for these other variables. So actually, why don't I format this a little bit? I'm going to say here age, and then I'm going to make a new line, and we're just going to say GPA. And again, I'm going to print out another one of these addresses, and we'll do one for grade, and we'll print out the address. So now I can just come over here and I can sort of modify this a little bit. So I can just say GPA and grade. And you'll notice for each of these I'm using this ampersand before I type out the name of the variable. So now when we run our program, we should get a nice little list of all of these variables and their corresponding addresses. So you'll see over here we have age, and it's stored at memory address 0060FFOC. GPA is stored at this memory address, and grade is stored at this memory address. So if you were to like go into our computer or go into my computer and go to memory address 0060FF0C, that's actually going to store the value of 30. It's going to store the value that's inside of that age variable. If you were to go to this memory address, you would see the value inside of GPA. If you were going to this memory address, you would see the letter, which was a capital A. So basically, all of these variables are stored at different memory addresses. When I want to access the information in the variable, I can just refer to the variable's name. So I could say age, or I could say GPA. But when C wants to access the information in the variable, it has to use these addresses. So C would use this address, C would use this address, and this address. I can just use the variable names, and that's why C is awesome, because it allows us to do stuff like that. But when C and when our computer wants to access these values, it has to use these memory addresses. And so that's why these are useful. And when we're programming in C, it can actually be pretty useful to be able to know the addresses, like the actual physical addresses of these certain variables in memory. So a lot of times in C, when we want to work with these variables, we can just refer to them by name, and we can do all sorts of stuff with them. We can access them, we can modify them. But in other circumstances, we're not just going to want to be able to access the value, we're also going to want to be able to access their physical memory address. In other words, we're going to want to be able to know like what that address is, and we can use that for a bunch of stuff. And in future tutorials, I'm going to talk about, but for now, I really just wanted to kind of give you guys an overview of what memory addresses are, how we're using them in our program, and how we can print them out. So again, I just use this ampersand, and then I type the name of the variable, and I use this %P to print it out. In this tutorial, I want to talk to you guys about pointers in C. Now a pointer is basically just a type of data that we can use inside of our programs. So up until this point in the course, we've been using a bunch of different types of data, right? We've been using things like integers, and an integer is just a whole number. We've been using things like doubles, and a double is a decimal number. We've been using chars, and a char is basically just a character. And now I want to introduce you guys to another type of data, which is called a pointer. And a pointer is basically just a memory address. And a memory address basically refers to a physical address inside of the memory of our computer where we're storing a value, right? And I think pointers tend to confuse a lot of people learn about them, and this is sort of one of those topics in C that everybody dreads because it's, traditionally very confusing to understand. But actually pointers are extremely simple, and the problem is that they just get overcomplicated. So what I want you guys to do is I just want you guys to think of a pointer as a type of data. That's all it is. It's just a type of data that we can work with in our programs. It doesn't have to be any more complicated than that, right? I can work with an integer in my program. An integer is a whole number, right? I can work with a double in my program. A double is a decimal number. I can work with a char in my program. A char is just a character. I can work with a pointer in my program. A pointer is just a memory address. That's it. A pointer is just another type of data that I can use and I can work with inside of my programs, and it just happens to be a memory address inside of the memory or the RAM in our computers. That's all it is. It's very simple. People overcomplicate pointers, and they don't have to be overcomplicated because it's just another type of data, just like an integer or a double. But instead of being like a whole number or a decimal number, it's a memory address. So hopefully that makes sense, and I hope that you guys don't try to overcomplicate this too much because it doesn't have to be. So down here in my program, I have an integer that I've created, and it's called age. So I just said int age, and inside of this integer age, I'm storing a whole number. I'm storing an integer, right, 30. And if you've been following along with this course, in the last tutorial, we talked about memory addresses, and we talked about how all of these variables are actually storing these values at physical addresses on our computer's memory. So down here, I have this print statement, and I'm just printing out age's memory address. And I'm using this %p, and I'm just printing out ampersand age. And we talked about how this ampersand, when I put this in front of the variable, basically it's going to give me the physical address in memory where this variable, in other words, where this 30 value is stored. So if I run this program, you guys will see over here it says age's memory address, and it's this hexadecimal number, right? This is the physical memory address of the age variable. What did we just talk about before? Remember what I told you? Pointers are memory addresses. That's what they are. It's a type of data. A pointer is a type of data in our program, and it's a memory address, right? When I use this ampersand and I type out the name of a variable, this is giving me the memory address, right? I'm able to print out the memory address. So really, this is a pointer. This is a type of data in our program that is a memory address. Just like an integer is a type of data that's a whole number, and a double is a type of data that's a decimal number, and a char is a type of data that's a character, a pointer is a type of data that's a memory address. And this right here, this guy right here is a pointer. So it's just the memory address of the age variable. That's it. And when I want to print out a pointer, I can use this %p, and it'll allow me to print it out onto the screen, and everyone's happy. So essentially what I'm doing here is I'm printing out a pointer. When I say %p, I'm telling this printf function that I want to print out a pointer, and then I give it a pointer over here. I give it a physical memory address. That's what a pointer is. Now we understand, and hopefully you understand, that a pointer is just a type of data, right? It's just a memory address. And we can access the memory addresses of specific variables by using this ampersand and then typing out the name of the variable. And that can be pretty useful. Now that we understand that, I want to show you guys how we can work with these pointers. So over here I have an integer variable called age. And this integer variable is storing an integer value 30. I'm going to say that one more time. I have an integer variable, and this integer variable is storing an integer value 30. I could also create a double variable. So I could create a double called GPA, and inside of this double variable I could store a double value like 3.4. I could also create a char variable called grade, and inside of this char variable, I could store a character, A. I could also create a pointer variable. And inside of that pointer variable, I could store a pointer. Okay? So just like I stored a character inside of this character variable, and I stored a double inside of this double variable, I could store a pointer inside of a pointer variable. So we can actually store these pointers inside of a pointer variable. Now, here's where this is going to get a little bit tricky. When we create a pointer variable, we actually need a physical memory address, right? So when I create this integer variable, like I can just come up with a number right off the top of my head, right? I can just say like 30. When I create a double variable, I can just store whatever number I want to store. But when we create a pointer variable, remember, we're going to be storing a memory address. And I don't necessarily know any memory addresses like right off the top of my head. At least I don't know any meaningful memory addresses. So when I create a pointer variable, what I want to do is store the memory address of a variable that's already in our program. So I'm going to say that one more time. When I'm creating a pointer variable, inside of that pointer variable, I'm going to store the memory address of another variable inside of our program. So let's say that I wanted to create a pointer that would store the memory address of this variable over here. So that store the memory address of age, right? I can create a pointer just like this. So I could say int, an asterisk, and now I'm going to give this a name. So I'm going to give this pointer variable a name. And remember, this pointer variable is going to store the memory address of the age variable. And generally, when you're naming a pointer, you're going to start with a lowercase p, and then you're going to type the name of the variable whose memory address you're storing in the pointer variable. So I'm going to say page, right? Because this pointer variable is storing the physical memory address of the age variable. Now what I want to do is set this equal to the memory address of the age variable, which we can access using this ampersand. So I could say ampersand age. So now this pointer variable is storing the memory address of the age variable. I'm going to do the same thing down here for this GPA. So if I wanted to create a pointer variable that would store the memory address of the GPA variable, I could say double asterisk, and I'm just going to say pGPA, just like that. And I'm going to set this equal to the memory address of this double variable, which we can access using this ampersand and then the name of the variable like that. I'm going to do the same thing down here for this character variable. So I want to create a pointer variable which is going to store the memory address of the character variable. So I'm just going to say char asterisk a grade, and I'm going to set this equal to ampersand grade. Okay? So that's all I'm doing, right? So now I have this integer variable, and I have this pointer variable which is storing the memory location or the memory address of the age variable. I have this double variable which is storing a double, and I have this pointer variable which is storing a pointer, and the pointer just happens to be the memory address of the GPA variable. I have this char variable down here, and then I have this pointer variable which is storing a pointer which just happens to be the physical memory address of the grade variable in our memory. Okay? And that's basically all you need to know about pointers to get started. A pointer is just a type of data. It's just a type of information that we can work with in our programs. It just happens to be memory addresses, right? An integer is a type of data that we can work with in our programs, and it just happens to be a whole number. A double is a type of data that we can work with in our programs, and it's a decimal number. A char is a type of data that we can work with in our programs, and it's a character. A pointer is a type of data that we can work with in our programs, and it's a memory address. Hopefully that makes sense. And just like we create integer variables and double variables, we can also create pointer variables. The only difference is whenever we create a pointer variable, we're going to store the memory address of another variable in our program. So you'll see over here, when I create this pointer variable, I'm using the data type of the variable whose address I'm storing. So over here, when I'm storing the address of an integer variable, I'm saying int here. when I'm storing the address of a double variable, I'm saying double here. When I'm storing the address of a char variable, I'm saying char here. And that's the basics of using pointers and also creating pointer variables and storing memory addresses inside of variables.
Gemini, what's Portuguese for I love you?
Amont. I love that on set. I love actually. 2003.
Amonte. Thanks, Gemini.
See? I told
In this tutorial, I want to talk to you guys about dereferencing pointers in C. Now, a pointer is basically just a type of data that we can work with in our programs that is a memory address. So sometimes in our programs, we're going to want to work with memory addresses. We're going to want to use them in our programs and do certain things with them. And those memory addresses are basically called pointers in our programs. And when you dereference a pointer, essentially what you're doing is you're going to the memory address of that pointer and you're grabbing the piece of information from there. Right? So all pointers are memory addresses, and when we dereference a pointer, we go to that physical memory address and we get the information, or we get the value that's stored inside of there. So I'm going to show you guys how we can do that in C. It's actually really easy and can be pretty useful. So down here I have this integer, and it's an integer variable, and it's storing the integer value 30. And over here I have a pointer variable which is storing the memory address of 30. So it's storing the memory address of our age variable, as you can see right here. And down here I'm just printing out this pointer. So I'm printing out page, I'm using this %p, and I'm just printing it out to the screen. So why don't we take a look and see what we get. So you'll see over here we just get this memory address, probably exactly what you expected to get. So over here, I want to show you guys how we can dereference a pointer. So this pointer variable page is storing the memory address of this age variable, right? So when we printed it out, we basically were given the physical memory address where this number 30 was stored. So page is storing the memory address of 30. It's storing the memory address where this value is inside of our computer's memory. If I want to dereference a pointer, basically what I'm going to be doing is I'm going to be going to that actual physical memory address and grabbing that piece of information. So the way that I can dereference a pointer is by using the asterisk. So when I'm printing this pointer out, I can dereference it by using this asterisk. But now over here, since I'm dereferencing this pointer, I need to print out a number instead of a pointer. Because when I dereference the pointer, this is no longer a pointer. This is no longer a memory address. Now, this is going to be whatever was stored at the memory address to point to. So this is going to be an variable, the address of integer. Right? So when I dereference it, here you guys, I'm going to run our program. It should print 30. So you'll see there we get a 30. So basically what happened here is we're referencing the page pointer, which basically means we're going to the actual address that the pointer is pointing to, and that's why we get 30. That's basically what dereferencing is. You know, you have a pointer, you can dereference it, you basically just get the value that it was pointing to. It's essentially all we're doing. So I want to show you guys how we could do this just normally. So, for example, I have this age variable. If I just typed this out, if I wanted to get the address of this age variable, I could use this ampersand, right? That's basically what we did. What I could do is I can just dereference this. So I can say ampersand age, and then I can put an asterisk here and dereference the entire thing. So now when I run my program, it's going to print out 30. So it's not going to print memory address, it's just going to print out 30. So you can see over here we get 30. So I could actually do this like as many times as I want, and this is an illustrative thing. So I could put an ampersand here, and now I'm going to get that memory address again. So you'll see we're getting this memory address. And I could do the same thing, so I could dereference this one more time. And you'll see now we're getting that 30 value again. So, I mean, basically what I'm doing here is I'm constantly, like here I'm getting the memory address where the age variable is stored. then I'm dereferencing it and getting the value, then I'm getting the memory address again, and then I'm dereferencing it again. So, hopefully that makes sense. When you dereference a pointer, you're basically just getting the value that that pointer is pointing to, or you're getting the value that's stored in the memory address of the pointer. In this tutorial, I'm going to teach you guys how to write to files in C. One of the cool things we can do in C is we can actually modify and change and also create new files. So in this tutorial, I'll just basically show you guys how to do that. We'll talk about creating files, writing files, and appending onto files. So let's go ahead and do that. Down here in my main function, we're actually going to create a file. So I'm going to create a file, and I'm going to store some information inside of that file. And the way that we can do that is we can just type out file all in caps, just like that. And essentially what we're doing here is we're creating a pointer to a physical file on our machine. So I'm just going to say file, and I'm going to make an asterisk, and I'm just going to give this a name. So I'm just going to call this F pointer, and that'll just stand for file pointer. And I want to set this equal to fopen. And fopen is actually a function that's going to open a file for us. So inside of these parentheses, I'm going to give this a couple different parameters. The first parameter is going to be the name of the file that I want to open. So I'm just going to call this employees.txt. And the second parameter is going to be a file mode. And a file mode is basically just going to tell C what we want to do with the file that we're going to open. And there's a bunch of different file modes. The three most basic types are R, and R stands for read. So if I put R in there, it'll mean we want to read the file. W stands for write. So if I put write in there, it means I want to either create a new file or write over an existing file. And there's also A, which stands for append. And that means I want to append information on the file. In this tutorial, we're going to look at W and A. So what I want to do over here is put in W. And right now, employees.txt, this file doesn't actually exist. So what I'm going to do is I'm actually going to create that file. We're going to put some information inside that file, and then that file gets saved onto my machine. And in order to do that, we're going to need this write mode. So it's just going to be a W. Anytime that we're opening a file in C, you always want to make sure that you close the file. So over here, I'm saying fopen. And down here, I want to use another function called fclose. And basically what this is going to do is it's going to close off the file. So it's going to remove the file from the memory on our computer. And if we do make any changes, it'll kind of like save the file, and everything will just be kind of like locked in. So you always want to make sure whenever you're working with a file that you close it. And inside of this fclose function, we just want to pass in this fpointer. So I'm just going to say fpointer right there. So let's talk about what's happening here. File is basically just like essentially like a data type, I guess, and we're creating a pointer to a physical file on our computer. So if you remember, a pointer is basically just a memory address. Right? A pointer is a type of data that we can use in our programs. It's essentially just a memory address. And this pointer is storing the memory address of this new employees.txt file that we're going to create. So essentially what's going to happen is we're going to create this employees.txt file, and fpointer is going to be pointing to the memory address of that file on our computer. So that's essentially what's happening here. And
I checked Allstate first and saved hundreds on my car insurance. Unfortunately, I didn't check if doing the Georgia bark at my boss would be appropriate. Go, dogs!
Yeah. So we need
Well, at least I checked Allstate first and saved hundreds.
Fancy Feast Gems. Turn the everyday into the extraordinary.
And what I want to do is I actually want to write some information to this file. So actually, let me just show you guys really quick what's happening here. So without doing anything else, just using this line right here. When I run my program, a new file called employees.txt is going to get created. So over here, I'm in my little directory, and if you don't specify an absolute path or like a relative path for this, it's just going to create it in the directory that your C file's in. So if I wanted to create this on my C drive, I could say like C whatever, and then like employees.txt, and this will get created in my C drive. But if I don't specify like an absolute path, or even if I don't specify a relative path, then this is just going to get created in the same directory as our C file. And you'll see over here, my main.c file is right here. It's in this folder. So when I run this program, let's watch over here and we can see this employees.txt file get created. So I'm going to run my program. And you'll see over here that this employees file got created. So if I actually bring this out a little bit, you'll see it's a text document, employees.txt, and there's 0 kilobytes inside of this. So we haven't put any information in there, but this file got created. So now let's talk about putting some info into that file. Inside this file, I'm basically just going to list out a bunch of like employees that might work in an office. And the easiest way to write information to a file is just to say fprintf. And this is a special function in C, which actually works a lot like the printf function. So if you've used the printf function, and if you're following along with this course, we've been using it throughout the entire course. The printf function basically allows you to like print information out onto that console window. Fprintf is going to allow us to essentially just write information to a file. I need to give this a couple parameters. The first one is going to be this file pointer. In other words, I need to tell this function, what it should be writing to. So I'm just going to say fpointer. And then over here, we can just give this some information. So I can just use, like after we put in this file pointer, I can just use this like I normally would the printf function. So I could just print out like some employees. So I could say like, let's say one of the employees is Jim, and we'll put like what they do. So like I could say salesman, and then we could say, actually let's make a new line, and we'll create another employee, Pam, and she is the receptionist, and then we can make some other employees. So now I have 3 employees that I'm going to basically write out to my employees file. So now when I run this program, and we can go over here to this employees file, you'll see when I open this up that we have these 3 lines in here. So we have Jim salesman, Pam receptionist, and Oscar accounting. So basically I was able to create this file and write all of this information in the file from down here, just from down here in this program. So that's pretty cool. And I want to show you guys with write. So when I'm using this write, this is actually going to overwrite a file. So for example, if I change this from all this text and I just put like overridden in here, now when I run this program and we open this employees.txt file, let me reopen this, you'll see it just says overridden. So I've actually overridden all of the text that was in there. And that's basically what happens when we just write to a file. So let's go back to what we had before. I'm just going to run this again. So we have this text. And you'll see now we're back with the employees. So let's say that inside of this file, we wanted to add an employee onto the end of it. So we wanted to add like a new employee onto this file, right? Well, I can use something called append. And what append is going to do is it's going to allow us to append a new line onto the end of this file, or actually just append text onto the end of the file. Instead of saying W, I'm just going to say A, and you'll notice I'm still keeping employees.txt here. And down here inside of this fprintf, I'm just going to print out another employee into the file. The first thing I'm going to do is print out a new line, because, and actually let me show you guys this in this employees file, there actually isn't a line after this last line. So the last position in this file is over here. I can't actually get onto the line below Oscar. So I'm going to want to go ahead and print a new line, and this will move the next employee onto the next line. We could say like Kelly, and she's going to work in customer service. So now when I run my program, instead of overriding what was in the employees.txt file, now this is just going to append this new employee onto the file. So I'll come up here, run the program, and let's open this employees file, and you'll see now we have another entry, Kelly from customer service. So when we write a file, we either create a new file and add content onto it, or we just overwrite the content.
Cause Stella got the juice. Stella got the juice. Stella got the Stella got the Stella got the juice. 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 wet butt.
Hi there, Stella.
Delta.
much you can actually control that. Waste signing. Can I borrow $50? I can do with that. Just apply for the Apple spread. You don't get approved, they still give you $50 just for a try. It takes like 2 minutes, and if you do get approved, you're eligible for $1,000. Just stop sleeping. Even if you have no credit, bad credit, please do say yes.
I was so excited to find out that you have an invoice gift. Have a clear background, right enough plate.
That's hilarious.
Operating system like Windows? And can you do it using Python? What is it?
So this one is cool. You basically connect your shop account and it's able to pull in your product catalog. And then from there, you can actually choose the exact product that you want to demonstrate.
Yeah.
All right.